Hello friends, we will see straight line in 3D geometry. We have gone through the equation of a straight line in 2D geometry. We will see how to write the equation of a line in 3D geometry. Earlier we have gone through direction ratios, direction cosine, and these basic things will be used to find the equation of a straight line in 3D geometry. What was very important form in 2D geometry was one point slope form. Here the same thing is very important, one point direction ratio form. So the first form we will see here is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. This is x1, y1, z1 is a point through which the line is passing, and a, b, c are the direction ratios of the line. You can also write the direction cosines instead of direction ratios. Sometimes cosines given, you can write the cosines here LMN like this fashion. So anyway, if we get one point and the direction ratio of a line, we can get the equation of line very easily. That is the Cartesian form. Cartesian form of straight line. We will also see the vector form of a straight line. Same way, one point slope form. The equation of a line passing through a point and parallel to a given line is given as vector r is equal to vector a plus lambda into vector b. What is a? A is a vector, is a point through which the line is passing. Here the point is x1, y1, z1. So the point will be x1i plus y1j plus z1k here for vector A. This is a position vector, be careful. And vector B is a line, is a vector to which it is parallel. It is not the position vector, be careful. Now we will see 2-point form, and we won't find some different equation, we will derive it from here only. So the 2 form can be written as x minus x1 by a. That means direction ratio. If 2 points are given, the direction ratio is, we have earlier seen, you just write x2 minus x1, y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Very easy 2-point form, equation of a line passing through 2 points. But how to write in vector format? Suppose a line is passing through vector A and vector B. These are the 2 points. Then the equation will be vector R is equal to vector A passing through 1 point plus lambda times the vector to which it is parallel. Suppose A and B are 2 points. You just see how we used to find vector AB. You remember position vector of B minus position vector of A. So it will be written as vector B minus vector A. So this is going to be vector A plus lambda into vector B minus vector A. So if 2 points are given, we can find the vector equation as well. We have to be conversant with the Cartesian as well as vector form, because sometime we will see vector forms is making our work easier. Now see question number 1. Find the vector and Cartesian equation of line passing through the points this and that. What is that? Point A is 3, minus 2, minus 5. Point B is 3, minus 2, 6. 2 points are there and we have to find the vector equation. What we did? We just got in this fashion vector R. R means nothing special. It is the resultant vector. if you just break it down, it is actually xi plus yj plus zk. This is nothing special. Vector r is equal to vector e, that means 3i cap minus 2j cap minus 5k cap. This is vector e plus lambda times vector ab. What is that? Position vector of B minus position vector of A. So it is coming out to be 3 minus 3, 0 I cap, minus 2 minus 2, 0 J cap, 6 minus minus 5, 11 K cap. So this is the vector equation of a line passing through 2 points. So now we have to write the Cartesian equation. We got it, x minus x1, this is 3, y minus y1, z minus z1, divided by x2 minus x1, 0, y2 minus y1, 0, z2 minus z1 is 11. You can derive that equation from the vector equation very easily. These are the one point it is passing through, and that is the direction ratio of a line to which it is parallel to. So the 2-point form we got very easily. Now go to question number 2. Find the coordinates of the point where the line through this and this crosses the YZ plane. Firstly, we will find the equation through 2 points. What is that? That will be x minus 5. You just write in this fashion, y minus 1 is equal to z minus 6 divided by x2 minus x1 minus 2, y2 minus y1, this is 3, and this is minus 5. So this is the equation of a line passing through 2 points. Now we have to see where it is cutting YZ plane. Where it is cutting YZ plane, that means no x is there. So x has to be 0. So point will be in the fashion 0, something like that. So we will put x is equal to 0. What we are getting? 5 by 2, 0 minus 5 is minus 5 by minus 2 is equal to y minus 1 by 3. So we will get the value of y and z very easily. So y is coming out to be 15 by 2 plus 1 and z is coming out to be minus 25 by 2 plus 6. So y is what? You will see 17 by 2 and z is what? You will see minus 25 plus 12, that is minus 13 by 2. So the point where it is cutting YZ plane is 0, 17 by 2, minus 13 by 2. So this is the point where it is cutting YZ plane. Hope you are now conversant with the different forms of straight line, Cartesian form and the vector form. Thank you. For useful videos, subscribe to my channel Santosh Pembi on YouTube or log on to my website www.mathsonphone.com. Thank you.